In this video, we're going to take a look at literal equations. We're going to solve for one variable. A literal equation is basically an equation that has two or more variables. Oftentimes we think of these as formulas, and we'll use them to solve for specific variables, making the formula easier to work with in a particular situation. As far as you're concerned, this is going to be an opportunity for you to flex your equation solving muscles, as oftentimes there's not a number involved, and that makes this a little trickier. But the process is the same as previous videos. So in these following equations or examples, we'd like to solve for an indicated variable, and then once we have done that, evaluate using the given values. So volume equals length times width times height is the equation that's given, and they want us to solve for width. On the right side of this equation, length times width times height, it's all multiplication. The inverse operation of multiplication is division, so we will divide both sides of the equal sign by the unwanted factors. In this case, length and height. And now we have W by itself equal to volume over length times height. For the second part of the question, we'll substitute in the given values. W equals volume 30 over length 3 times height, which is 2. And again, anytime we substitute, it's helpful to use parentheses. This will cut down on a multitude of mistakes in future problems for you to develop this habit. 3 times 2 is 6. 30 divided by 6 is 5. Units. It's a good habit also to include units, whether they're given or not. So oftentimes they might say inches or feet, or there might be a time increment like seconds or minutes that you'll use. With formulas and word problems, attaching the unit of measure to your answer gives that number value meaning. Number 2, I equals P plus R, solving for P. You may find it helpful to circle the term or even the variable specific that you are solving for. We see that R is added to P. So to get rid of the R and moving it to the left side of this equation, we want to use the inverse operation of addition, which is subtraction. And if we do that on the right side of the equal sign, we need to do the same on the left side to keep this equation balanced. I minus R equals P. We have now solved for P because P is isolated. This is our new formula. And we can find what P equals when I is 70 and R is 14. 70 minus 14 is 56. A equals B plus C minus D. We're solving for C. So again, it may be helpful to circle the term that we are isolating. And we see this is subtraction, so we're going to add D to both sides. A plus D equals B plus C. Again, we still want C by itself, so we're going to subtract B from both sides of the equal sign and have A minus B plus D equals C. We can now find the value of C when A is negative 1 minus B, which is negative 2, plus D, which is negative 3. Here's a case where the parentheses are helpful again, because we see we're subtracting a negative. Well, that's the same thing as adding a positive. So negative 1 plus 2 minus 3. If we're adding a negative, that's the same thing as subtraction. Negative 1 plus 2 is 1, minus 3 is negative 2. Example 4. S equals 2t minus 3v. We're solving for v. The term that includes v is negative 3v. I need to take the positive 2t and move that to the left by subtracting. The inverse operation here of the positive, that addition. Since the 3v is a new term, we know it's a subtraction situation here. So S minus 2t equals negative 3v. We have isolated the term that includes v, but we have not isolated v yet. V has a coefficient of negative 3. Negative 3 times v, the inverse operation is division. So we divide by negative 3. And we'll need to do that on both sides of the equal sign. So v equals S minus 2t divided by negative 3. What is v when S is 6 and t is negative 10? There is multiplication in the numerator that needs to take place first, the negative 2 times negative 10. And so we'll have 6, negative times a negative is a positive, 2 times 10, 20, divided by negative 3. Six plus 20 is 26, divided by negative 3. And our final answer could be left as 26 or negative 26 thirds, or as a decimal, negative 8 and 7/10. Either would be acceptable answers here. In some cases, a decimal is preferred. Other cases, a fraction is preferred. It really all depends on the situation. In example 5, we're looking at the slope-intercept form of a line. This is a very common formula that we use in algebra. Y equals mx plus b. M is the slope, b is the y-intercept. We're solving this for m. So again, maybe we circle the term that includes the m, and we see that we must subtract b from both sides of the equal sign. Y minus b equals mx. We see that m is multiplied by x here, and we're solving for m, so we need to divide both sides by x, and then m equals y minus b all divided by x. Now we can find the slope m given y as negative 8 minus b, which is negative 10, all divided by x, which is negative 2. A negative 8 minus a negative 10 is the same thing as negative 8 plus 10. Negative 8 plus 10 divided by negative 2. Negative 8 plus 10 is 2 divided by negative 2. This simplifies to m equals negative 1. I know this topic is quite challenging, and you might be watching several of these questions over and over again. Every formula is a little different, but if you follow the addition property of equality, the multiplication property of equality, as we've used in other videos, simplifying algebraic expressions and solving equations, the processes are the same whether there are numbers in the equations or not.